this video, we are going to talk about logarithms. So if we have log base a of mn, how will we write the expansion for this? The rule says that this is equal to log base a of m plus log base a of n. What about log base a of m over n? The rule says that this is equal to log base a of m minus log base a of n. The most important thing is that when m and n are multiplying, then we are going to add their individual logs. But when m and n are dividing, then we are going to subtract their individual logs. Usually, the log of the denominator from the log of the numerator. What about log base a of m exponent r? The rule says that this is equal to r log base a of m. There are common mistakes that people make in logarithms. For example, what is the expansion for log base a of m plus n? This is not the same as log base a of m plus log base a of n. The principle of logarithms does not work like this. You can expand this as in binary operations, so that you multiply log a to m and multiply log a to n. This is not true. Another one is log base a of m minus n. This is also not equal to log base a of m divided by log base a of n. Another common misconception is log base a of m all exponents r. This is also not equal to r log base a of m. So we need to get the differences. It is rather log base a of m exponent r that is equal to r log base a of m. It is not the same as into bracket log base a of m all exponent r. So these are the difference between these two. And also here is log base a of mn. They are multiplying, but it is not the same as in this case where they are adding. And this one too is not the same as this case where it is m minus n and not m over n. So these are the common mistakes that people make in logarithms that we must take notice of. Now let's come to the change of base of logarithms. For example, if you have log m base n, this is the same as log m, maybe let's say base b divided by log n base b. So this is actually known as the change of base. It is log m in any base divided by log n in any base. Anytime you see log a where they don't specify the base, then you take the base as base 10. Anytime it is written as log but there's no base down here, you just have to assume that the base is in base 10. Write log base a of into bracket x times square root of x squared plus 1, where x is greater than 0, as a sum of logarithms, and express all factors as powers. So we have log base a times x square root of x squared plus 1. So we see that x is multiplying square root of x squared plus 1. But remember that we said log base a of m times n is equal to log base a of m plus log base a of n. So it's the same thing we'll use here. So this is equal to log base a of x plus log base a of square root of x squared plus 1. So this is equal to log base a of x plus log base a of square root of x squared plus 1 is the same as x squared plus 1 all exponent 1 over 2. And now remember what we said. We said log base a of m exponent r is the same as r log base a of m. So what we'll do is that we'll push this 1 over 2 down here. So the answer becomes log base a of x plus 1 over 2 log base a of x squared plus 1. Write log base a of into bracket square root of x squared plus 1 divided by x cubed times x into bracket x plus 1 exponent 4, where x is greater than 0 as a sum of difference of logarithms. Express all powers as factors. So the log is log base a of x squared square root of x squared plus 1 divided by x cubed into bracket x plus 1 exponent 4. So this is the log that we were given. Remember that log base a of m divided by n is the same as log m base a minus log n base a. So that's what we are going to use here. So since this and this are dividing, it's going to be the log of the numerator minus the log of the denominator. So this is equal to log base a of square root of x squared plus 1, then minus log base a of x cubed into bracket x plus 1 exponent 4. So we can write this as log base a of x squared plus 1 all exponent 1 over 2 minus. You see that this x cubed and x plus 1 exponent 4 are two different functions that are multiplying each other. And remember what we said. We said log base a of mn is equal to log base a of m plus log base a of n. So that is what we are going to use to expand this to. So it's going to be minus into bracket log base a of x exponent 3 plus log base a of x plus 1 all exponent 4, bracket close. And then remember what we said. Log m exponent r is equal to r log m. So let me put a base a here. So log m base a exponent r is equal to r log m base a. And this is equal to half of log base a of x squared plus 1 minus, we use the same thing here, 3 log base a of x. Then minus times this, we make this plus minus log base a of x plus 1. But remember that this is also exponent 4, so we can bring the 4 to the back here, and it becomes minus 4 log into bracket x plus 1. Write each of the following as a logarithm. A. Log base a of 7 plus 4 log base a of 3. B. Log x base a plus log 9 base a plus log into bracket x squared plus 1 base a minus log 5 base a. So the a part is log 7 base a plus 4 log 3 base a. So this is equal to log 7 base a plus, using this identity, or let's say using this formula, see that log m exponent r base a is equal to r log m base a, and the opposite is also true. So that means in moving from here to here, we just bring the y up on top of m. So here becomes log base a 3 exponent 4. Now the value of log 7 base a plus the value of 3 exponent 4 is 81, so log 81 base a. Then you remember that log m n is equal to log m plus log n. So the opposite is also true from here, and therefore this is equal to, we can write this as a single log. That will be log base a of 7 times 81, and this is equal to log base a of 567. So let's come to the b part. We were given log x base a plus log 9 base a plus log x squared plus 1 base a, then plus log 5 base a. So in writing this, sorry, here is supposed to be minus log 5 base a. So since this and this are plus, then it will multiply. This one will also multiply, they are plus. So we are going to multiply this, and this. And then since the sign here is minus or negative, then we'll divide by what? 5. So in writing this as a single log, it's going to be log into bracket x times 9 times x squared plus 1 divided by 5. So this is equal to log x times x squared will give us x cubed. So 9 times x into bracket x cubed plus x times 1 is x divided by 5. So at the end of the day, the answer is going to be log 9 over 5 times x cubed plus x. But remember that the base was what? It was in base a. So let's repeat it. Base a, base a, base a. There is also another property of logarithms that we must understand, and that is if log base a of m is equal to log n base a, then it implies that m is equal to n. So let's use that understanding to solve some questions. Let's solve log x plus 6 base 5 plus log x plus 2 base 5 equals 1. So what do? Since we are adding this log, then we need to use the formula log m base a plus log n base a equals log mn base a. So this then becomes log x plus 6 times x plus 2 base 5 equals 1. Then now, another property of logs are, if we have log m base a equals 1, then it implies that m is equal to a exponent 1. It's the same thing if we have log, let's say log b, let me use small b, log b base 2 equals 1, then it implies that b is equal to 2 exponent 1. So it's the same thing here. So this implies that into bracket x plus 6, then another bracket x plus 2 is equal to 5 exponent 1. So let's go ahead and expand and look for the values of x. So x times x is x squared plus x times 2 is 2x plus 6 times x is 6x plus 6 times 2, 12. Then 5 exponent 5 is 5. 5 exponent 1 is 5. Then I'm bringing that to this side. It becomes minus 5 equals 0. So this then becomes x squared plus 8x. 12 minus 5 is 7. So plus 7 equals 0. So we are supposed to look for two numbers that when you multiply, you get 7. But when you add, you get 8. So you see that 1 times 7 is 7. However, 1 plus 7 is 8. And therefore, the factors becomes x plus 1 in one bracket, then x plus 7 in another bracket equals 0. So x is equal to minus 1 or minus 7. So solve 3 log x minus 1 base 2 plus log 4 base 2 equals 5. So what we will do is that this is equal to 3 log 2 log base 2 x minus 1, then plus 4 can be written as log 2 exponent 2 base 2 equals 5. So we can then push these two down. So this becomes 3 log x minus 1 base 2 plus 2 log 2 base 2 equals 5. Now there is an important formula, which is log a base a is equal to 1. Remember what we said about change of base. Log a base a can also be written as log a base b divided by log a base b, and this will cancel this, so it will give us 1. And therefore, log 2 base 2 is 1. So this becomes 3 log into bracket x minus 1 plus log 2 base 2 is 1. So times 2 is 2. So plus 2 is equal to 5. 3 log x minus 1 is equal to 5 minus 2, which is 3. So we can divide through by 3. We divide through by 3. We divide through by 3. So it means that log into bracket x minus 1 is equal to 1. Then we know that, let me continue from here. This is the same as, okay, they give us a base of 2, so the base was 2. So x minus 1 is equal to 2 exponent 1. And therefore x is equal to 2 plus 1. And x is equal to 3. So we are supposed to solve log x squared minus 9 base 4 minus log x plus 3 base 4 equals 3. So let's write these two as a single log. Since the sign here is negative, then we need to divide this one by this. So this is equal to log base 4 of x squared minus 9 divided by x plus 3 is equal to 3. Now this is equal to log. 9 can also be written as 3 squared. So it becomes x squared minus 3 squared divided by x plus 3 equals 3. So this is equal to log. X squared minus 3 squared is difference of 2 squares. And that becomes x minus 3 in one bracket and then x plus 3 in another bracket divided by x plus 3 is equal to 3. So this x plus 3 and this x plus 3 can cancel. So that we'll get log to bracket x minus 3 equals to 3. Therefore, x minus 3 is equal to, the base of this log is log 4. So it's equal to 4 exponent 3. And x minus 3 is equal to 4 exponent 3 is 64. And therefore, x is equal to 64 plus 3. Therefore, x is equal to 67. Given that log a base 2 is equal to 3, and log b base 2 is equal to minus 2, and log c base 2 is equal to 5, evaluate log a times square root of a exponent 5 times b divided by c cube base 2. So it is log 8 times square root of 8 exponent 5b all over c cube. So this is equal to, using the product rule, which is log m times n base b is equal to log m base b plus log n base b. So this then becomes log 8 base 2 plus log, let me write this as a exponent 5b divided by c exponent 3 times half, because the square root of a number is the same as that number exponent half base 2. So this is equal to, 8 can be expressed as 2 exponent 3. So log 2 exponent 3 base 2 plus, then I'm shifting this half down, it becomes half log a exponent 5b divided by c exponent 3 base 2. So yes, a exponent 5. So this is equal to, we'll bring this 3 down, so it becomes 3 log 2 base 2 plus half. Then now this a and b are multiplying, so we open a bracket, and that becomes log a exponent 5 base 2 plus log b base 2. Then it is divided by c cube, so it becomes minus log c cube base 2. So this is equal to, remember what we said, log a base a is equal to 1. So log 2 base 2 is 1. So this becomes 3 times 1 plus half of, then we can bring this 5 down, so it becomes 5 log a base 2 plus log b base 2 minus, can bring this 3 down, 3 log c base 2. So we're having 3 times 1 plus half into bracket log 5 log a base 2 plus log b base 2 then minus 3 log c base 2. But inside the question, remember they give us, so 3 times 1 is 3 plus half of. But the question said that log a base 2 is equal to 3. So log a base 2, all of that is equal to 3. So this becomes 5 times 3 plus. Then log b base 2 was given as minus 2. Then minus 3 log. Log c base 2 was also given as 5. So minus 3 times 5. So this is equal to this. It's equal to that. And it's equal to 3 plus half of 5 times 3 is 15 minus 2 minus 3 times 5, that's 15. So you can see that plus 15 minus 15 can cancel out. So at the end of the day, we will have 3 plus half times minus 2. Now half of minus 2 is minus 1. So it becomes 3 minus 1. And 3 minus 1 is equal to 2. Evaluate 2 log 5 base 10 minus half log 16 base 10 plus 4 log 2 base 10. So this is equal to log 5 exponent 2 base 10 minus log 16 exponent 1 over 2 exponent 1 over 2 base 10. So let me put the 16 in brackets, then plus log 2 exponent 4 base 10. So this then is equal to log 5 exponent 2 base 10, then minus log 16 exponent half. The exponent half is the same as log root 16 base 10, and root 16 is 4. So this becomes minus log 4 base 10, then plus log 2 exponent 4 is 16. So that becomes 16 base 10. So this is equal to, let's then write them as a single log. It is 5 plus log 16. So this and this are added and subtracted from 4. So we'll multiply these two and divide by 4. So 5 exponent 2 is 25. Okay, so let me write all of this. So this becomes log 25 base 10 minus log 4 base 10 plus log 16 base 10. So this is equal to log 25 times 16 divided by 4. And this is equal to 20. This 4 will cancel this 4 times. So 25 times 4 is 100. So there's base 10 here. So this becomes log 100 base 10. But we know that 100 is the same as log 10 exponent 2 base 10. So we can bring the 2 down, and this is equal to 2 log 10 base 10. And remember what we said earlier, log a base a is equal to 1. So this is equal to 2 times 1, and the final answer is 2. So given that log A base 10 is equal to P plus Q, and log B base 10 is equal to P minus Q, express A log A exponent 3, B exponent 3 base 10, and then B log into bracket A over 100 B. So let's start from A. Log A exponent 3 times B exponent 3. So we were given log A and then log B. So we are supposed to express this log in terms of log A and log B. Then we can then use it to write it in terms of P and Q. So this is equal to log A exponent 3 plus log, since they are A and B are multiplying, plus log B exponent 3. But we are working in base 10, so here's base 10. And this one too is base 10. And this is equal to, we can bring the 3 down, becomes 3 log A base 10 plus 3 log B base 10. And this is equal to, they've given us the value of log A base 10. It is P plus Q. So this becomes 3 times P plus Q, then plus 3 times. They've given us the value of log B base 10 is P minus Q. P minus Q. So we're having 3 times P plus Q, then plus 3 times P minus Q. So 3 times P is 3P, plus 3 times Q is 3Q, then plus 3 times P is 3P, minus 3 times Q is 3Q. So you see that plus 3Q minus 3Q can go away. So this is equal to, so at the end of the day, it becomes 3P plus 3Q, and that becomes 6P. So the B part, it says that we should evaluate log base 10 of A over 100B. So this is equal to log A base 10. Here's 10. So log A base 10 minus log 100B base 10. And this is equal to log A base 10 minus log 100 base 10, then plus log B base 10. And that is also equal to log A base 10 minus 100 is the same as 10 squared. So we can put 2 down so that we get, so this is equal to log A base 10 minus log 10 base 10 is just 1, so 2 times 1 is 2, then plus log B base 10. So let's continue from here. Remember that from the question, log A base 10 is P plus Q. So this becomes P plus Q, then minus 2 brackets 2 plus log B base 10 is P minus Q. So this becomes P minus Q. So P plus Q, then minus 1 times 2 is minus 2. Then minus 1 times P becomes minus P. Then minus 1 times minus Q becomes plus Q. So we see that plus P minus P can cancel. Q plus Q is 2Q. Then minus 2. So when we factorize 2 out, so this is equal to this, and it's equal to that. So if we factorize 2 out, we'll be left with Q minus 1. Find the possible values of x for which log x minus 2 base 5 plus log x minus 6 base 5 is equal to 1. So And then the b part is log 9 base root 3 is equal to x. So let's start with the a part. So we can write all of this as a single log. And that is log x minus 2 base 5 times, since they are adding, they'll multiply x minus 6 is equal to 1. So x minus 2 times x minus 6 is equal to 5 exponent 1. So x minus 2 times x minus 6 is equal to 5. So we can then expand the bracket. X times x is x squared. X times minus 6 is minus 6x. Minus 2 times x becomes minus 2x. And minus 2 times minus 6 becomes plus 12 equals 5. So let's bring everything to the left-hand side of the equation. So it becomes x squared minus 6x minus 2x becomes minus 8x. Then plus 12 minus 5 equals 0. So let me continue from here. So we then have x squared minus 12 minus 8x. Then plus 12 minus 5 is plus 7 is equal to 0. So we must look for two numbers that when you multiply, you get plus 7. But when you add, you get minus 8. So you see that minus 1 and 1. Minus 1 times minus 7 is positive 7. However, minus 1 minus 7 is minus 8. Therefore, this becomes x squared minus x minus 7x plus 7 is equal to 0. So we can factorize x out. X minus 1 and minus 7 out. X minus 1 is equal to 0. And therefore, in one bracket, we have x minus 7. Then in another bracket, we have x minus 1 equals 0. So the values of x are x equals 1 or x equals 7. Then the b part says that log 9 base root 3 is equal to x. So what we can do is that this can be written as 9 equals root 3 exponent x. And then this is equal to 9 can be written as 3 squared equals, and then root 3 can also be written as 3 exponent half 1 over 2, then times x becomes half x. So since they have the same basis, then we can square the exponents. So it becomes 2 equals 1 over 2x. And therefore multiplying through by 2, we can see that x is equal to 4.